Welcome. In this video, we will go through the typical configurations of the Southern Photonics IQScope. The IQScope is shown here below an equivalent time oscilloscope, and it's connected to an optical transmission source. Here, we're demonstrating a 28 gigabaud single pole QPSK source. In this video, we will describe typical setups for both single pole and dual pole configurations. We'll also show some typical configurations using the local oscillator from the IQScope, as well as using the local oscillator from your own transmitter. So the IQScope works with three of the most popular equivalent time oscilloscopes. It works with the 86100 series of the Agilent oscilloscopes. It works with the 8300 series of the Tektronix oscilloscopes, as well as the Wave Expert from LaCroix. So in this first slide, we're showing a typical single pole configuration. So as you see here, the local oscillator originates from the IQScope, is passed into a 1090 splitter. The 10% path of the local oscillator goes back into the IQScope, and this functions as our local oscillator input, or our laser input. The 90% path goes to your modulator, and that's where the QPSK or QAM or OFDM signal is applied to your optical carrier. The output of the modulator is then passed back into the IQScope through the modulated signal input. On the output of the IQScope, you have four electrical connections. In this case, they're connected to an 86100D, or the Tektronix 8300, or the LaCroix Wave Expert. These four connections will then be sampled and interpreted by the IQScope software, which can run directly on the oscilloscope or on a standalone PC. Now, a second example of a configuration is where you use the local oscillator from your own transmitter. So here, the local oscillator is split in the transmitter. One path goes to the internal modulator in your transmitter, and then that modulated signal is then passed into the modulated signal input into the IQScope. The second path is your local oscillator input, which gets passed into the local oscillator input into the IQScope. And the electrical connections are the same as the previous example, so four connections to the equivalent time oscilloscope. So that's all it takes to set up a single pole configuration. Now, an alternate configuration is the dual pole setup. In the dual polarization setup, you can characterize any arbitrary state of polarization, and you can characterize, obviously, the intensity and the phase of any arbitrary optical signal. In order to characterize a dual polarization setup, you need to use the Tektronix 8300, since it has 8 electrical connections. So in this slide, you see the familiar configuration slide that you've seen before. The only difference is that there are now 8 electrical connections on the output, connecting up to the Tektronix 8300. So that's it. Those are typical configurations. Now you know everything you need to know to set up your own IQScope. For more information on the software or how the IQScope can be used for you, please visit southernphotonics.com or visit our other YouTube videos. Thank you very much.